In mid-October 2024, SpaceX successfully completed a feat that was only thought possible in sci-fi movies a few decades ago. They effectively caught a rocket the size of a 20-story skyscraper from space with a pair of giant chopsticks. You don't have to be an engineer to know how difficult that is. Simply put, it looks like a rocket reattaching to a station. To the untrained eye, it's no different to launching any other rocket. The SpaceX landing just changed space travel forever. Catching a 20-story building hurtling through the Earth's atmosphere at up to Mach 3 and slowing it down to be caught with giant mechanical arms is crazy. But how is it done? Well, it's thanks to Mechazilla. Mechazilla is the name of the towering pair of mechanical arms attached to SpaceX's launch tower. Its main purpose is to catch the Super Heavy booster after it's separated from Starship after launching it into space. This system eliminates the need for a booster splashdown or a landing on hard ground, of course reducing refurbishment and hence saving costs and time. Before Starship Flight 5, SpaceX conducted 4 previous test flights. They each provided valuable data and insights, though not all were successful. During these earlier flights, the Super Heavy boosters either exploded shortly after takeoff or crashed into the ocean during landing attempts. This is actually pretty normal in the process of figuring out such a massive engineering challenge. But the SpaceX team went back to the drawing board, figured out what went wrong, and now, this time, the results were different. So, on October 13th, the 71-meter tall, or 233 feet, Super Heavy booster detached from the upper stage at an altitude of 65 kilometers and then began its descent. As it fell, the boosters utilized 13 of its 33 Raptor engines to slow down its descent and steer the massive structure towards Mechazilla. The real magic of this catch lies in the precise coordination between the booster's guidance systems and Mechazilla's robotic arms. The Super Heavy controlled its descent with grid fins. These are essentially large metal waffle-like panels near the top of the booster. These fins act like aerodynamic brakes, steering by adjusting how air flows around it during re-entry. They allow for quick, fine-tuned adjustments as the rocket descends through the atmosphere and help it glide towards its target. These fins work alongside the thrusters to ensure that the booster aligns perfectly with the tower. At the same time, Mechazilla's chopstick arms, equipped with advanced sensors and actuators, moved in perfect harmony to grab the booster. This reduces wear and tear on the rocket and significantly cuts down recovery time. In a stunning display of engineering, the booster hovered just above the launch tower before Mechazilla's arms swooped in and secured it for rescue. This success demonstrated that the technology works, setting a new standard for rocket recovery. Generally speaking, these reusable rockets have driven big improvements in navigation systems. A combination of real-time GPS data, onboard sensors, and sophisticated algorithms constantly track the rocket's position and make split-second adjustments to its flight path. This allows SpaceX boosters to land not only on solid ground, but also on a moving ship in the middle of the ocean with pinpoint accuracy. And as we've seen, these improvements didn't happen overnight. They're the result of continuous testing and learning from each launch. Just pure engineering goodness. And this precision isn't just for show either. It's essential for future missions. Imagine manned missions to the moon being frequent and reliable, while being able to take a massive payload too. And if we do get lofty, perhaps deeper space would be unlocked with this technology too. But what does this all really mean? Well, of course, reusable rockets are cheaper, 65% cheaper according to a study published by the University of California. But on top of that, the chance of going over budget is 30 times lower, and that's a huge deal. Plus, reusable rockets burn less fuel than their single-use counterparts. While still not great for the environment, at least it's better. But these cost savings don't just benefit SpaceX, they open up access for more companies. Take a small satellite startup, for example. Launching on a reusable rocket makes their mission far more affordable. On top of that, companies can share payload space, making it easier for ever smaller missions to get off the ground. But this creates a different kind of problem. As space becomes more accessible and affordable, naturally, more companies would want to launch their own satellites into orbit. As visible in this animation, space is already crowded, and when things crash into each other up there, it gets messy. Take a look at this graphic created by Professor Moraba Jar and his colleagues. You see that red ring of particles? Well, those are countless pieces of old rockets. And here in Australia, we're starting to see parts of SpaceX space junk land in the country. This is a part of a SpaceX capsule that landed in the Australian outback a couple of years ago. While space agencies are working to tackle this problem, it's a challenge that's only going to get tougher as the number of launches continues to rise. But despite these challenges, the usefulness of reusable rockets shouldn't be overlooked. The implications of Mechazilla's success go far beyond cutting costs. It also enables the frequency of launches to drastically increase. NASA has already tapped SpaceX to use a version of the Starship for lunar landings. Mechazilla would go a long way to making these missions faster and more affordable. Additionally, being able to catch a booster mid-air offers an advantage for landing on difficult terrain. Take the Moon, or even Mars for example, where using conventional landing pads just isn't practical. But of course, at this present time it's a bit of a catch-22, because you have to fly something out there with the construction materials and astronauts to actually build the first structure. But as it currently stands at this point, this is already pretty fascinating. So to SpaceX and all the engineers on that team, you've done a great job. It's like they're not just dreaming of the future, but they're actually building it, one groundbreaking catch at a time.